Try this one. So if I have something grouped together, I want to set it in put it in a parentheses. Sometimes those parentheses are very important mathematically, and sometimes they aren't. So when parentheses matter and when they don't is a really important idea of this chapter. Really, I would say that's the main idea of this chapter, when parentheses matter and when they don't. So how to write expressions with parentheses, understanding what that means, so that you can write an equivalent expression without any parentheses. So in other words, what do the parentheses mean, and can I write the same thing that doesn't have that grouping together? Sometimes the usefulness of parentheses is sort of psychological. You don't need to have them written down mathematically. That won't change the meaning of the expression if you erase the parentheses or if you write them down, but sometimes it helps you to remember that things are grouped. And that's typically in rational expressions or expressions that are written like a division. So that's what that means, rational, like they're written like a ratio. So I don't know if this is a big idea, this is a definition, but to factor something means to write it as numbers or symbols which are multiplied together, and to factor something out means to write an expression as that something that you factored out times something else. And lastly, drawing boxes is often just a really useful way to keep track of writing a new expression that is an equivalent to an old expression that has parentheses in it. Okay, so the first thing I'm going to ask you, if I have 2 plus 3, I'm going to group that together, and then I'm going to say plus 5. I'm going to say, do those parentheses matter? So I think a lot of people learned order of operation. It has a mnemonic PEMDAS. Please excuse my dear Aunt Sally. Some of you learned. That's not what I learned. I did learn. Actually, I never learned that you needed to do parentheses first, and I think that really helped me in my mathematical education, because you do not need to do parentheses first. That is it's like a false shortcut. Because look at this expression. Do you need to add the 2 and the 3 first before you add the 5? Let's say I added the 3 and the 5 first, and then I get 2 plus 8, right? That equals 10. Let's say I've added the 2 and the 5 first, and then I would get 7 plus 3, that equals 10. So in this expression, those parentheses don't matter, and you absolutely do not need to do what's in the parentheses first. Now you might ask, well, maybe I want to do what's in the parentheses first just because it wouldn't hurt. You're right, it wouldn't hurt, but let me show you something. Okay, look at this expression. I have negative x plus 2, all in parentheses, plus x. If you thought that you needed to do what's in the parentheses first, you would be stuck because you don't know what x is, so you can't add it to 2. So you're stuck, you can't do anything. You're like, okay, well, I have this thing, it's all together in parentheses, and I'm adding that to x. I don't know what to do because I can't, or not I don't know what to do, but I can't do anything more because these are together. But if you know that if in this expression those parentheses don't matter, in other words, I can just erase them, and it means the exact same thing, then negative x plus x is just 0, so I get 0 plus 2, and that's equal to 2, right? So knowing when parentheses matter and when they do not matter can help you simplify expressions. If you are adding, the parentheses never matter. So think about this. What parentheses mean are these things are grouped together. And adding means combining. I'm just throwing stuff together. So like I have a negative x. I'll call that like an IOU. Say like it's I owe somebody some money, so it's like a debt. I have a debt, I have $2, and I have some money. If I throw them together into my bank account, it doesn't matter what order I throw those things together. It doesn't matter if I put my debt in first and then the $2 and then the money, or I put the $2 first and then the money and then my debt. The order never matters. So if the order never matters, it doesn't matter how you group them. So you might as well just group them in any way you like. You could erase the parentheses and put new parentheses in to tell yourself what order you're going to do it. So if originally there were parentheses there, I'm like, I don't want to do that first. What I'm going to do is I'm going to do negative x plus x first. right? That's exactly the same thing because the parentheses don't matter. You could have them there sort of psychologically to remind yourself that you're going to do that first, and then you're going to get 0 plus 2. So when you are adding, the parentheses never matter. You can erase them, you can stick them wherever you like. What about if you're subtracting? So remember, there are two definitions of subtracting: removing or finding the difference between two things. Let's look at the first definition, removing. Let's say I have 9 and I want to remove, let's say I have $9 and I want to take some money out of it. My daughter says, can I borrow $4 from you? And I said, no, she says she wants to borrow $6 from me. And I said, sure, I have $9 in my purse. I know that I have a 5 and a 1. So you take that 5 and the 1 out. So she goes in and she grabs the 5 and the 1 together in her hand, right? And she removes it from 9. So this is what is going on there. The 5 and the 1 are grouped together because they're in somebody's hand, and that whole thing is being removed from 9. Do these parentheses matter? In other words, can I just erase those parentheses and would it mean the same thing? So do these parentheses matter? Could I erase them? If I erased them, I would get that, okay? And without parentheses, and if all you're doing is adding or subtracting, you just read the expression from left to right. So 9 minus 5 is 4, and 4 plus 1 is 5, okay? But if I had 9 minus 5 plus 1, what actually happened? I had $9 in my purse. We grouped 6 of those dollars together, and then we removed them. So it's 9 minus 6, and that equals 4. So those parentheses, these parentheses right here, yes, they absolutely do matter. If you erase them, you're going to get an expression that is not equivalent to your original expression. So to recap, if you're adding, it doesn't matter how you group numbers, but if you're subtracting, it could matter how you group them. If you're subtracting a bunch of things that are combined, it means you're subtracting each of them individually, or it would be equivalent to subtracting each of them individually, right? So my daughter, I had $9 in my purse. I could have told her, take the 5 out and then take the 1 out, right? That's the same thing as telling her, put the 5 and the 1 in your hand, group them together, and then remove them. So these expressions are the same. Some people have learned that this is called distributing this subtraction into every term in the parentheses. I'm not that concerned whether you're learning whether you're learning terms like mathematical terminology in this class. I just want you to think about meaning. I feel like that's more important than memorizing the terminology. Okay, multiplying. In the chapter on multiplying, you learned that it never matters what order you multiply numbers, right? And we had exercises where I said, what's 9/4 times 27, all divided by 1/3, all times 153, and you learned that you can rearrange the order of multiplication so that you can do those kinds of problems easier, right? So if it never matters what order you if it never matters what order you multiply numbers, if all you're doing is multiplying, then the parentheses would never matter, right? It wouldn't matter how you group them together. So for example, if I have 2 times 5 times 3, right? Do I have to do what's in the parentheses first? Let's find out in this example. Let's say it's 2, 5 times 3 is 15, 2 times 15 is going to be 30. Okay, that should be a parentheses there. So that's doing what's in the parentheses first. Let's if I did 2 times 5, if I did 2 times 5, all times 3, that's going to be 10 times 3, that's going to be 30. So if all you're doing is multiplying, this is just one example, but if all you're doing is multiplying, the order you multiply numbers never matters. You can rearrange the order that you are multiplying in any order you like, and you can erase the parentheses and stick them wherever you like. The same thing as adding. If you're adding numbers, the order never matters. If you're multiplying, the order never matters. So it doesn't matter that you do what's in the parentheses first if all you are doing is multiplying. Okay, well, what about that? What about that? Please excuse my dear Aunt Sally business. What's the deal with having parentheses and you have to do what's in the parentheses first? It's an oversimplification that leads people into errors. So be careful. You do not need to do what's in the parentheses first. You do need to understand what parentheses mean. However, beyond that, the MDAS part of it, you do want to pay attention to that because exponents, which we haven't even covered exponents in this class, we will in the next chapter, that means repeated multiplication. So like x squared, that means x times x, or 5 to the third means 5 times 5 times 5. It's not 5 times 3, it's 5 times 5 times 5. If you have expressions and you don't have any parentheses, so there's no parentheses telling you what you have to do first or what's grouped together, there's no parentheses telling you what's grouped together, you have to rely on this exponents, multiplication, division, adding, and subtracting. Okay, and you have to do these operations in this order, sort of, but not really, because as you know, multiplication and division are two sides of the same coin, right? If I multiply by 1/3, it's the same thing as dividing by 3, right? So you could do division first, you could do multiplication first, because they're the same thing, right? And you could add and subtract, because as you know, you can turn any subtraction problem into adding its opposite. Okay, so what does this mean? If I have an expression that has no parentheses, like 3 minus 2 times 4. So there's no parentheses. There's nothing telling you there what's grouped together. However, there is something there that's grouped together because this multiplication groups the 2 and the 4 together. So this is the same exact thing as 3 minus 2 times 4 with the 2 and the 4 in parentheses. I like writing it like this all the time, so I never get confused by thinking this is 3 minus 2, which would be 1, times 4, which would be 4. That's not the case. Because of order of operations, this 2 and the 4 have to get multiplied first, so this is 3 minus 8, okay? Which is negative 5. It is not 1 times 4 equals 4. Okay, it's not 3 minus 2 equals 1 times 4 because you have to do what's being multiplied before you do any addition or subtraction. Okay, let's say I have things that are grouped together that are added. Let's do 2 plus 3. Okay, they're added together. And then onto that group, I'm going to do a multiplication. And my question is, so this is multiplying. Remember, if I have a number right next to a parentheses, it means multiplication. I could do that. That means multiplication as well. This means that I'm taking twice of 2 plus 3. So let's think about money. So in my purse, I have a $2 bill. Let's pretend. I have a $2 bill and I have a $3 bill. Let's just pretend there's such things as $2 bills and $3 bills. Okay, I have a $2 bill and a $3 bill. And that's what's in my purse. And then I know that I've got twice that. What is twice that? It's the same thing as two $2 bills plus two $3 bills, right? I'm doubling this whole thing. That's going to be 4 plus 6, that's going to be 10. Okay, if you're watching this video, you should definitely be taking notes. First of all, because my whiteboard is tiny, so I need to erase it so you can't look back on what I wrote before. But look at this. What is another way of writing multiplication using addition notation, right? Multiplication means repeated addition. So this means 2 of this group, right? So this means I have 2 plus 3 and I have 2 plus 3, right? That's what multiplication means. I've got 2 of this thing. Okay, now all I have is addition. Once you have addition, it doesn't matter what order you what order you do that addition, right? So I have 2 plus 3 plus 2 plus 3, and I have 2 plus 2. I'm going to group those together, and I have 3 plus 3. All right, I have 2 2's and 2 3's. All right, that equals 10. So if you're doing multiplication of a group that has addition in it, is the same thing as taking however many repeats I have here. I have 2 repeats, right? 2 repetitions of this term and 2 repetitions of this term right there. I'll show another example in a sec. Okay, so let's repeat something 3 times. What am I repeating 3 times? I don't know. I literally do not know. I'm repeating some x's and I'm repeating some y's. How many times am I repeating that thing? I'm repeating it this many times, 3 times. Right? Which leaves me with 3 x's plus 3 y's. I can't combine those because I have no idea what x is. X might be 1 billion and y might be 17. Okay, so I can't simplify this any farther. I have no idea what x and y mean. But I do know that if I've got 3 of the combination of x and y, if I have 3 of the combination of x and y, is the same thing as saying I have 3 x's and 3 y's. Compare that, I'll use this side, with 3 x, y. Okay, this is not the combination of x and y. This is some multiplication of x and y. So I have y repeated x times. Say I have y repeated x times, then repeat that 3 times. This is all multiplication. And so this is just 3 times x times y. Those parentheses do not matter. These parentheses do not matter. What about this? If I have 3 plus x plus y, do those parentheses matter? All I'm doing is adding things. It never matters what order I add them, so it doesn't matter that I would add those first, even though they're grouped together in parentheses. I don't need to do that addition first. That would just be 3 plus x plus y. So here the parentheses don't matter. I can just erase them. Here the parentheses don't matter. I can just erase them. Here they definitely matter. If I erased them, I would not get 3 x's and 3 y's. If I erased them, I would get that, and I wouldn't have enough y's because I'm repeating the y 3 times, and if I just erase the parentheses, it's telling me that I'm not repeating the y 3 times. Okay, in those examples we did, when you're adding, it never matters what order you add numbers, and so you can group them any way you like. And if they are grouped for you in parentheses written down, you can just ignore those parentheses. You can just erase them. If you are multiplying and you have some of those numbers that are multiplied together, grouped together, you can just erase that. You can just erase that parentheses and group them however you like. You can reorder the multiplying. If you're subtracting, the parentheses might matter, and you always have to do the if you have exponents in an expression, you have to do those first. Those are grouped together even if you don't have a parentheses. If you have multiplication and addition, you have to do the multiplication first. Multiplication is the flip side of division, so you have to do multiplication and division first. And then you'd have to do your adding and subtracting last, in the absence of any parentheses. Okay. When might parentheses be really helpful for you to add to an expression to remind you what it means? And one of the cases when it might be really good to add parentheses even if the original expression doesn't have any is when you are dividing. So if I had m plus n all divided by 2. Think about this. Actually, I'm going to make it real. If I had 4 plus 6 all divided by 2. Okay. Sorry, I keep changing my mind. Let's do 2 plus 6 all divided by 2. Okay, there are no parentheses there, but everything above that fraction bar is grouped together, and so you can write it. And the reason it's often helpful to write that in a parentheses like that is to remind you that it's this whole thing divided by 2. Because what students want to do sometimes, they're like, oh, 2 divided by 2 cancel out. Excuse me, 2 divided by 2 cancel out and I get 1. And so my answer is 1 plus 6 equals 7. But that's not right, because it's this whole thing divided by 2. It's the 2 divided by 2 plus the 6 divided by 2, and I get 1 plus 3 equals 4. Or you can do what's in the parentheses first and do 2 plus 6 is 8 over 2. And what is 8 divided by 2? That's 4. Okay, so when you have expressions where you have something divided by something else, you might want to put whatever is in the numerator in the top of your division problem. You might want to put that in parentheses. You might want to put what's in the bottom in parentheses. Let me show you another example. Let's do 2 times 6 all divided by 2. Okay? So look at that. I'm going to do what I just told myself to do and put that in parentheses. Put that in parentheses. And then does this 2 go into 2 and then the 2 go into the 6? Remember, division, you can rewrite any division in terms of multiplication. Dividing by 2 is the same thing as multiplying by 1/2. I've turned this division into multiplying. Now I have those in parentheses, but all I'm doing is multiplying. I'm multiplying 1/2 times 2 times 6, so the parentheses don't matter. And when I read it like that, you have 2 times 1/2 is just 1 times 6, and I end up with 6. And I want to compare that with this. Okay, I write that. I'm going to write parentheses. Okay. Now, instead of saying 2 divided by 2 and 6 divided by 2 like I did a minute ago, I'm going to turn this dividing by 2 into multiplying by 1/2. Okay, think about that. This is similar to that example where I said if you have subtracting, like you're taking stuff out of my purse, you have to subtract things individually. Or if I'm doubling a sum, if I'm doubling a combination, it means every term in there gets doubled. Here, everything in here gets halved. So what's half of 2 is 1, and what's 1/2 times 6 is 3, and I get 4. So in this case, this grouping together, this parentheses actually is really important. And in this case, it is not important at all, because in this case, all you're doing is multiplying, and it never matters what order you multiply. If you have addition and multiplication and addition and division mixed up together in the same expression, then the parentheses are important. They're telling you what is grouped together. Okay, one thing that I think is really helpful for a lot of students when you're thinking about multiplication and you're multiplying a bunch of things that are added together to a bunch of other things that are added together is to think about multiplication as finding the area. Even if you're not finding the area, even if your multiplication has nothing to do with finding the area, right? Part of math is taking an expression and finding an equivalent expression that you know has the same answer. So you can take actually like a phenomenon that you know can be described by the same equation. So even if you're not finding the area of something, you can, excuse me, imagine that you're finding the area of it if you're multiplying one thing to another. So consider this example. If I have, let's say, what is 120 times 54? Okay. Now let's just pretend we all don't have phones in our pockets and we can't just do that on a calculator, 120 times 54. So I'm going to draw, I'm going to say, even though I know nobody's talking about a rectangle here and finding out what the area of this rectangle is, it doesn't matter. I'm going to pretend, because I know whenever I multiply one thing to another, I can pretend that I'm finding the area of a rectangle with one side has the one thing that I'm multiplying and the other side has the other thing I'm multiplying. So I have a rectangle here. Here's 120, and here's 54. Okay. So that's the length. What I'm going to do is I'm going to say I'm going to make 120. I'm going to make it easier. I'm going to call that 100 plus 20. It's really important here that I'm thinking plus 20. I didn't call it times anything. I mean, I could have. But what I'm doing is I'm cutting up the length of one of the sides of this rectangle into pieces, and those pieces added together equal my original length, not multiplied, they're added together. So 100 plus 20, and then here I'm going to call this 4 plus 50. So this whole thing is 54. This is a little 4. I mean, this is not to scale, right? That's a little 4, and this is 50, and here's 100, and there's 20. Okay. So the area of this whole rectangle is going to be the area of this rectangle plus the area of this rectangle plus the area of this rectangle plus the area of this rectangle, right? And the area of a rectangle is one side times the other. So what's 100? So this is 100. What's 100 times 4 is 400. What's 100 times 50 is 5,000, right? 100 times 50. What is 4 times 20? 4 times 2 is 8. So that's going to be 80. And this is 50 times 20 is going to be 1,000, right? 5 times 2 is 10. So I have 1,000 there. So the area of this whole rectangle is going to be 5,000 plus 1,000 plus 400 plus 80. So it's going to be 6,480. So 120 times 54 is 6,480. Okay, you could very reasonably be saying what the point was of that. What is the point of that? If you already know how to multiply, or you can get out a calculator and do 120 times 54. Yeah, okay. But check this out. What if someone said, I want you to simplify. I want you to find another expression that is x plus y times a plus b plus c. Okay. Okay, and I say, do these parentheses matter? Absolutely they matter, right? Because I'm repeating this thing, a plus b plus c. I'm repeating that, but I'm repeating that some unknown number of times. But if I wanted to say, write an equivalent expression to this expression, but one that doesn't have any parentheses in it. This is not solving. It's not an equation. I can't solve it. I can just write an equivalent equation. I can just write an equivalent expression to this. And I'm going to do it by thinking that this is actually asking me, I can imagine that it's asking me, what's the area of a rectangle if one side is x plus y and the other side is a plus b plus c? The important thing here is to note that this is plus, like you have to see it. You have to see expressions that this is adding, not multiplying. This is adding a plus b plus c. And that whole thing, a plus b plus c, is multiplied to x plus y. So if I'm multiplying two expressions together, it's as if I'm finding the rectangle. One side is one expression, and the other side is the other expression, and I'm multiplying them together. Okay, so it's adding a plus b plus c. So this whole length is a little bit that's a, and a little bit that's b, and a little bit that's c. And this whole length is x, and this is going to be y. Okay, well, that means that I cut this piece into 3 pieces. I don't know how long A, B, and C are, so I just randomly kind of made them even. But they could, like, A could be tiny and B could be huge. But it's 3 pieces, and this side is 2 pieces, right? So what's this? This length right here is A. This length right here is x. So this little rectangle is A plus x. This little rectangle is A. Did I say A plus x? I meant A times x. This is A times y. This is b times x. This is b times y. This is c times x. This is c times y. The area of this whole rectangle is this plus this plus this plus this plus this plus this. Not times, plus, right? I'm adding up these little areas. So my whole area is going to be ax plus bx plus cx plus ay plus by plus cy. Okay? Drawing it out helps you keep track. You may have learned like FOIL or other acronyms. This you couldn't FOIL this because there's 3 terms in here. But some of you like draw rainbows, little rainbows up there, right? That's fine if it works for you. But a lot of people then keep track, or they lose track of what they've multiplied to what. And drawing it out in a box, it uses a little more paper, but you're not going to make errors. Okay, the other thing that I talked about in this chapter was factoring. So to factor something out means to write an expression as that something times other things. So if I said 9, if I said factor out a 3, you could say that's 3 times 3. If I said 2xy, if I said factor out an x, you could write x times 2y, right? I've factored out an x, so it's by itself times those other things. If I said x plus 2, and I said factor that by factoring out, I don't know, x, you could say, well, that means I need to write this as something times something. So this is x times, and I have parentheses. Well, I've factored out an x, so this has to be 1 right here. I divide that by x, and then I divide that by x. That has to be 2 over x. So I've factored out an x, which means that my result is x times something, that if I did that multiplication, I'd end up with what I started with. So I factored out an x by dividing that by x and getting 1, dividing that by x and getting 2. And I could check it. If I'm going to multiply again, I get x times 1 plus x times 2 over x would just be 2. So that's what to factor out means. Okay, so if you looked at this expression, 2x plus 8 over 16x plus 8. Okay, and you're told to simplify it. Okay, well that means this whole thing divided by that whole thing. And I look at it and I'm like, I don't know, I can't really tell how many times this thing goes into that thing or what part of this thing goes into that thing, right? But I could factor it and see if that gets me anywhere. So let's factor this. Are there any common factors, meaning something multiplied to something else, common to 2x and common to 8? And there's 2. So 2 goes into 2x and 2 goes into 8. So I wrote 2x plus 8 as 2 times x plus 4 because they're the same, because if I multiplied 2 times x, I get 2x, 2 times 4, I get 8. Could I factor something out here? What could I factor out? What goes into 16x and what goes into 8? Well, 8, because 8 goes into 16 twice, so I could have 8. So 8 into 16x would go 2x, right? Because 8 times 2x is 16x. And then 8 times 1 is going to be 8. So I end up with that. And I'm like, oh, well, look at that. 2 over 8. 2 over 8 is 1/4. Right? X plus 4 in parentheses over 2x plus 1 in parentheses. And then I'm done. I can't really do anything more with that expression. Okay, so there are a lot of exercises in this chapter. You should go through all of them. If you have any questions at all, send me an email, ask me about that. Remember, it never matters what order you multiply or divide numbers. It never matters what order you multiply numbers. And you can always write any division as a multiplication. It never matters what order you add numbers. And you can always write any addition as a subtraction. You know how to do that. Parentheses do matter if you're subtracting a group of things, a combination of things, right? Then you're subtracting each individual term. Like if that was this example, something like that, right? I'm subtracting the 2 and I'm subtracting a 3. Okay, so those parentheses matter. Think about the box model for multiplication. If you're multiplying some things that are added and if you're multiplying some things that are subtracted. So remember, if I'm doing 2 plus 3, let's do 2 plus x, and then 3 plus x versus 2 times x, 3 times x. These parentheses matter, these parentheses don't matter. I'm not adding there at all. This is the same thing as 2 times x times 3 times x, right? That'd be 6 times x times x. Or 6x squared if you like. That's exponential notation, but we'll get to that next week. This is the same thing as 6 times x times x. This thing you might want to do the box model because it's 2 plus x and a 3 plus x. Okay. 3 times 2 is 6, 3x, 2x, x times x. So the area of this whole thing is going to be 6 plus 3x plus 2x plus x times x. 6 plus, and what's 3x plus 2x is 5x plus x times x. Okay? Because here I have 3 x's and here I have 2 x's, which combine to make 5 x's. Okay, that's the end of chapter 13. Good luck.